In this lesson, let's learn about recurrence relation and factorials. 参加式、階差数列。an plus 1 minus an equals bn. Number sequences expressed by recurrence relation, like the one on the right, have a factorial sequence with bn. We will use this to solve the next example. Find the general term of the sequence of numbers defined by the following conditions. a1 equals 1. an plus 1 equals an plus 2 to the power of n. Let's think about what kind of number sequence it is. Since it can be transformed as an plus 1 minus an equals 2 to the power of n, we can assume that the sequence has a factorial of 2 to the power of n. Let's use the formula to find the general term of a factorial number sequence. an equals a1 plus sigma from k equals 1 to n minus 1 when 2 is to the power of k equals 1 plus 2 times parentheses 2 to the power of n minus 1 parentheses over 2 minus 1, which equals 1 plus 2 to the power of n minus 2, which equals 2 to the power of n minus 1. Let's examine a case when n equals 1. Since the first term is 1, the expression also holds true when n equals 1. Therefore, the general term is an equals 2 to the power of n minus 1. Now let's do some practice. Press the pause button and try to solve the practice problem. Once you're finished, press the resume button and mark what you got correct. Now let's check our answers. Since it can be transformed as an plus 1 minus an equals 2n, we know the sequence has a factorial sequence of 2n. From there, we will use a formula to find the general term of a sequence of numbers with factorial numbers. an equals a1 plus sigma from k equals 1 until n minus 1 when 2 is to the power of k equals 1 plus 2 times half parentheses n minus 1 parentheses n equals 1 plus n squared minus n, which equals n squared minus n plus 1. Since the first term is an equals 1, this equation holds when n equals 1. Therefore, the general term is an equals 2 to the power of n minus 1. Were you able to answer correctly? Finally, let's review what we have learned. an plus 1 minus an equals bn. Number sequences expressed by recurrence relation have a factorial sequence with bn. That concludes this lesson.